Right, so the first thing when you get a hyperbola, okay, the first thing you check for is you will see in grade 11, we're actually shifting the hyperbola left and right. I don't know if you remember, but in grade 10, we just shifted the hyperbola up and down. We didn't shift it left and right. All we did in grade 10 is we changed the 1 asymptote. Okay, we maybe said the asymptote will be at 2 instead of at 0, or the asymptote will be at -1. And the plus 2, remember in grade 10 it would be something like 2 over x plus 2, or -3 over x plus 1. And then we said that value that you add or subtract, a constant value, that is your asymptote. Okay? And that is this asymptote here. That's going to be your horizontal asymptote. So the first thing you can do is the same. You can say my constant value will be my asymptote. It's plus 2, so it's going to be at 2. If it was -2, it would be at -2. If there's nothing, if it was just like this, it would have been at 0. Okay? So if it's plus 2, you can say now I know I need to draw a dotted line here. Okay? And I call this line y equal to 2. That's what I call the line. And you can get a mark for showing there's an asymptote and for naming y equal to 2. Okay? Now the first thing that changes from grade 10 to grade 11 now, what we spoke about now, is this gives you your second asymptote. That is your vertical asymptote. Okay? So it works in the same way as the turning point. With the turning point we said it's the opposite side. Okay? So if it's x minus 1, then it's going to be plus 1, the asymptote. Okay? So at 1, x equal to 1, you make your second asymptote. Okay? X equal to 1. And then you name it x equal to 1. So we got our two asymptotes. Okay? So it's always, why is it the opposite sign? Because remember, an asymptote is a value that the graph never reaches. Okay? So think about it. Why can't the graph reach 1? The graph will never reach 1. It will never go through x equal to 1. Why not? Because what happens when you make x 1? 1 minus 1 is 0. And can you divide something by 0? No. You can never divide by 0. If you say 2 divided by 0, the calculator will say it's an error or undefined. Okay? You're probably going to say error. So you can't divide something by 0. So all you need to actually ask, if you want to find out what is your horizontal asymptote, your vertical asymptote, is what will make the denominator 0? 1 will make it 0. So I can say x equal to 1 will not work. I can't go through that. Now I can see, okay, so that's my asymptote, this is my asymptote. And because it's positive 2, okay, it's going to be in the first and in the third quadrant. Okay, mainly in the third quadrant and the first one. If it was negative 2, it would have been in the second and the fourth quadrant. So that's another thing you can remember. Okay, positive 2, first, third quadrant, negative 2, or just a negative there, second and fourth quadrant. Okay. But now, after you got your asymptotes, okay, which is probably going to be your first mark for getting both, now you need to find the x and y intercepts. Okay? And finding the x and y intercepts, you know what to do. You put it equal to 0 and solve. So let's first look at the y intercept when you make x 0. So when you say g0 equal to 2 over 0 minus 1 plus 2, okay, when you make x 0, you find your y-intercept. So this is going to be 2 divided by -1, which is -2, plus 2, which is 0. So that means this graph goes through 0. There. And x is 0, y is 0. So there's the intercept. So this is an interesting one because obviously you don't even have to find the x-intercept now. Okay, because think about it, if it goes through that point, it can't go through there also. So actually in this question, your x and y intercepts will be 0. Okay, now you can say, well, now what I do now is I substitute 1 or 2 more values just to see what the shape of the graph will be like. Okay, I plot some coordinates and don't put in too many. The more you put in, the more work. So I'm going to say, let's put in 2. Because if I put in 2, I'm going to get a coordinate somewhere around there, and then I can put in 3 and maybe and then I can connect it. And the same on this side. I can put in -1, get a coordinate somewhere around there. And then I can maybe put in, I can't put in 1, so I can put in a half. I'm going to put in those coordinates, and then we're going to see when we plot. Right, so we got in half, we got -2 out. Put in -1, got 1 out. Put 2 in, got 4 out. Put 3 in, get 3 out. And we plot them. There they are. And there. And now you just connect them. Then you get your graph. Okay, so this part will obviously from here to there, it's going to be something like that. Okay, that's your hyperbola on this side. Comes closer to the asymptote, but it doesn't go through the asymptote. The same there, it comes closer to the asymptote, but not through. Just like that. And this side, you can say it comes closer this way. And then you can even turn the page when you sketch it. Turn the page to make it easier to sketch. And there's the height, there's the asymptote. There it comes closer to this asymptote, but it never comes through, and it doesn't go up again. Okay, it must look like it's just getting almost in line with the asymptote. Okay, there's the hyperbola. And then sometimes they ask you to sketch the axis of symmetry. Okay, the axis of symmetry are the lines that makes the graph symmetrical. Okay, that's like a mirror in the middle. So an axis of symmetry is a line that's going to go through here, and that part looks like a reflection of this part. And it's a line that goes through like this, so that this part is reflected that way, and there, that part is reflected that way. So the important thing about the axis of symmetry is it's always where the two asymptotes connect. So they're in the middle, where the y equal to 2 and the x equal to 1 connect. That is where the axis of symmetry will go through. And then the one axis of symmetry will have a gradient of 1, and the other axis of symmetry will have a gradient of -1. Okay, so then you can put in the two axes of symmetry. Right, so the axis of symmetry, the one, because it has a gradient of -1, and it starts there, if it goes 2 units forward, 2 units down, or if you go 1 back, 1 up, gradient of -1. So it has a y-intercept of 3. This one is the gradient of 1. The one axis of symmetry always has a gradient of 1. The other one always has a gradient of -1. Okay, so you can then do it algebraically. You can figure out what's the y-intercept, or you can just know if it has a gradient of 1, then if I go 1 back, I must go 1 down. And for this one, if I go 1 back, I must go 1 up. Then in that way, you can also find. So this one will have an equation of y equal to -x plus 3. And this one will have a gradient of y, of an equation of y equal to x, because it's +1 plus 1, the y-intercept. Okay, and it's supposed to make a symmetrical line, a line so that that part looks like a reflection of that, and that's the hyperbola. It's quite a lot of work.